Now let's turn to the additional maths. We have the 2019 additional mathematics specimen paper over here. So the first question is this: x squared minus 8x plus 16 minus y squared is equal to. Now to solve this question, we must first of all factorize this expression. So when we factorize the expression, this is a trinomial. And you observe that we can split the middle term. But the factors of 16 that can add up to -8 is -4, -4. I know you know that already. So the next thing we do now is to proceed with the factorization. We factor x out here and -4 out here. Then we factor further, we collect like terms, we factor further to obtain this, and this is the same as x minus 4 all squared. So over here we are going to use this. So you recall that if you have a squared, difference of 2 squared, a squared minus b squared is equal to a plus b, then into b, a minus b. So we apply this property where we use a to represent all this. So the whole of this is a and this is b. So when you apply that property, we get something like this: x minus 4 plus y, and x minus 4 minus y. So this will give us something like this, and when we rearrange, we get this. Therefore, the correct option will be B. Now let us proceed to the second question. Find the remainder when f of x equals 4x cubed minus 3x squared minus x plus 1 is divided by x plus 2. So according to the remainder theorem, if f of x is divided by x plus a, then the remainder is given by f of negative a is equal to r. So if you plug in negative of this, we need to get the remainder. So how do you get negative a? Just equate this to 0 and solve for a. Now we plug in x equal -2 into this function to get -2. Wherever we see x, we replace with -2, and that will give you this. Let's now evaluate. This will give us -8, and this will give us +4, and this will give us +2 plus 1. Then the next thing we do now is to simplify further. 4 times -8 will give us -32. Then 3 times 4 will give us -12. That is -3 times 4 will give us -12 plus 3. So the next thing we do now is to simplify further. This will give us -44 plus 3 is -41. So the correct choice is B. The roots of the equation are, so this equation, we want to find the root. So let's go. We rewrite the equation. We can factor 3x plus 2 because it is common to both sides. So when we factor we obtain something like this. But first of all, let us rewrite this as this. Something squared means that thing by itself. So we now collect the common factors to get something like this. This one comes out, then this is there, plus x minus 5. Then the next thing we do now is to simplify the expression here to obtain something like this. So we rearrange and add 3x plus x give us 4x, then 2 minus 5 give us negative 3. Now by the zero product principle, we have 3x plus 2 equal 0 and 4x minus 3 equals 0. Therefore the roots are x equal negative 2 over 3, then x equal 3 over 4. So the correct answer is negative 2 over 3 and 3 over 4. Now we proceed to the next question. Given the quadratic equation 3x squared minus 2x plus 5 is equal to 0, then x is equal to what? So this is how we go about it. Let us repeat the question. We are going to use completing the square method. You can use the almighty formula also. So we subtract 5 from both sides, divide through by negative by 3 to make the coefficient 1. Then the next thing we do is to add half the square of this to both sides. So when we have this, when we have this negative 2 out of 3, then we are going to obtain negative 1 out of 3. So we square this, the result, and add to both sides. So that will be equal to 1 out of 9. So we add 1 out of 9 to both sides to get this. So this is now a perfect square. That is x minus this. That is x minus 1 on 3 all squared. X minus 1 on 3 all squared will give us this over here. So when we expand this, we get this. So it means when we factor this, we have to obtain this. Then we simplify this side, the right hand side, to get negative 14 over 9. Now the next thing we do now is to take the positive plus or minus square root of both sides. So we now add both sides by 1 over 3 to get this. We collect LCM to get this. So what do we do next? The next thing we do is to multiply both the numerator and the denominator by 2, because we can see that the result we had here, we don't have something like that. So we need to find an equivalent. You can see that both the denominators are all 6, meaning that we need to multiply this by 2. But whatever we do to the denominator, we must do to the numerator also. So that will give us this expression. Now let's expand the numerator to get something like this. Now root of 4 is the same as 2. By using the property of radicals, 4 can go inside to multiply. 4 times negative 14 will give us 56. So 4 times negative 14 will give us negative 56. So the result will be 2 plus or minus root of negative 56 all over 6. Therefore, the correct choice is 2 plus or minus root of negative 56 over 6. That's the correct answer. So let's proceed with this. The quadratic expression is this. And we want to rewrite in the form k minus a into x minus a squared. So we are going to use the completing square that we just did. We are going to use the same approach. So what do we do now? Let's factor -1 out to obtain this. Now note that taking -1 out, I have to create a negative here so that when we expand by we get positive. Now what do we do next? We create perfect square over here by adding half the square of this. So half of this is -2. -2 square before. We add and subtract to get something like this. This is a 0 pair, so nothing has changed. It's a 0 pair. Now what do? We want a trinomial, so let's cut off this. So it will be like an expansion. So it will be like we are expanding this and this. So this is like 2 times ab. So negative of a, then minus, so this becomes plus. So that is what we are doing. That's what we just did over here. Let me erase this so that you can get the clear picture. So that's what we just did. Now we can simplify further. This will give us 1, and this is the same as something like this, meaning that when we expand x minus 2 all squared, we get this. You can see the middle term is double both of these. So that is the property of a trinomial, a perfect square trinomial. So we do that to get x minus 2 all squared plus 1, and this is the same as 1 minus x minus 2 all squared. So the correct answer will be this option B. Why are we getting B? So let's move on to the next one. The diagram above shows the graph of which function? So we know this is maximum graph. For a maximum graph, you know the a will be negative. Negatives. So what do? Let's move on. We can see that this has a root at x equal -3 and x equal 1. So we have something like this. Now, by the factor theorem, we can rewrite this in factored form as this. We brought the a to provide for the coefficient over here. So someone can bring -a, someone can bring a. It doesn't change anything because it depends on what you are doing, the understanding of what you are doing, the concept. So we substitute this point over here because it is lying on the curve. At this point, x equals 0 and y equals 3, so it must satisfy this curve. And we now simplify this expression to get 3 equal -3a to get a equal -1. Therefore, our expression is this: the graph of this function y equal x minus 3, x plus 3, x minus 1. So this one. Now let's proceed to The seventh question: if alpha and beta are the roots of the equation x squared minus 5x minus 40 equals 0, then the value of 1 over alpha plus 1 over beta is what? So we have x squared minus 5x minus 40. So in this case, this is our a. A will be equal to 1. A is equal to 1. B is equal to negative 5. Then C equal negative 14. C equal negative 14. So alpha plus beta, which is the sum of the roots, is negative b over a. So let's sub in to get negative 5 over 1, which is the same as 5. Then alpha beta is c over a. So c is negative 14 over 1, which will give us negative 14. Therefore, 1 over alpha plus 1 over beta will be equal to this. We need to collect LCM, which is alpha beta, then we add to get this. Now the next thing we do is to substitute alpha plus beta, which is 5, and alpha beta, which is negative 40, and we had this result as our answer. Therefore, the correct answer will be option C. We have to solve this inequality. Now to solve this is an easy way to do it. It's a very easy way. So we draw our number line and illustrate these values on it. So to solve an inequality, we solve the corresponding equation. So the corresponding equation is this: x into x minus 5 is equal to 0. So now what do we do next? That is how come we got x equals 0 and x equal 5. Good. So that is the function of translating it into an equation. But we are not solving this equation, but we are solving an inequality. So we need to get a range of values for x. So how do we get that? We now know that this value that we solve for the equation has divided the number line, the real number line, into 1, 2, 3 regions. So we need to pick points to see which of them will satisfy this inequality. So when we pick a point which is less than 0, let's say negative 1, let's pick negative 1 and plug in here. Pick negative 1 and plug in. You're going to get negative 1 into negative 1 minus 5. So that will be equal to negative times negative, which is positive. Positive can never be less than or equal to 0, so that is false. So this region is not part of the solution. Now we can try this region too. Let's plug in 6. So 6 here, if you plug in 6 you get positive, if you plug in 6 you get positive. Positive is never less than or equal to 0, so that this region too is out. Now we can pick a point from within this range. So let's pick 1. If you put 1 here you get negative value, if you put 1 here you get positive. Negative times positive will give us negative, and this region satisfies the inequality. Therefore the solution set is this. And how do you write this as an inequality? So it is inclusive from 0 to 5. Therefore the result, the correct answer is this, which is corresponding to option C. Now let's look at the greatest integer satisfying the inequality x minus 5 squared less than 4 is. So with this we can also use the previous understanding. So we just solve this. We brought this here and brought this here. So we are using difference of two squares. So apply difference of two squares to obtain something like this. can simplify further to get this. So we move on to a number line again to obtain something like this. Now that we have this, we can use the number line to get something like this. We draw a number line, so x equals 4 is here and x equals 7 is here. So we divide our region into 1, 2, 3 again. Then what do we do next? We test. So let's pick a point from here. So let's pick 3. You put 3 here, you get negative. Negative. If you put 3 here, you get positive. So positive times negative will give you negative. Then let's pick another point here within this region. So let's pick, let's say 5. Let's pick 5. If you put 5 here, you get positive. Sorry. The first one, if you put 3 here, you get negative. You put 3 here, you get negative. So negative, negative. Negative, negative will give you positive. Positive is never less than 0. So this region is out. Then we test for this region too, and we realize that it's also out. Now what about this region? Let's put in 5. We put 5 here, we get 1, which is positive. We put 5 here, we get negative 2, which is negative. So positive, negative is positive. Positive, negative is negative, which is less than 0, and this region is true. But this time, our inequality will not be inclusive of the boundaries. This means that our inequality is going to be like this: x greater than 4 but x less than 7. And the numbers within this range are the integers within this range. We are talking about integers. So the integers within this range are, we have 5, and 6. These are the only integers that can be found within this range, and the greatest that is satisfying this is 6. Now let us look at the number 10. If a function f is defined by f such that x maps onto x plus 4 over x minus 1, then where x is not equal to 1, then f inverse of negative 5 is equal to what? Now let's go ahead to find the inverse of x. You can see directly that the inverse will be the same as this, but let's show that the inverse is still the same. It is reflexive. So f of x equal x plus 4 over x minus 1. We let y equal this. Let y equal f of x. So we make x the subject to get something like this. We cross multiply, expand, then we factor y, or we add y to both sides, then we factor x, and we are grouping the x terms. Factor x to get x into y minus 1, then divide both sides by y minus 1 to get this. And the next thing we do is to swap x and y. So if you swap x and y, you get y equal x plus 4 over x minus 1. So it implies that the inverse of f of x is x plus 4 over x minus 1, which is the same thing. So it is reflexive. Now to find the inverse of negative 5, we plug in negative 5 to get this. So this is a self-inverse. The function has itself as the inverse. So we plug in this to obtain negative 5 plus 4 over negative 5 minus 1, which is equal to 1 over 6. So the correct answer will be option D. Now if you can still see this red in here, it means you have not yet subscribed. So you just have to click it so that the next upload, you see it is still red. You have to click it so that if I upload the next video, you'll be informed. Click the bell icon too so that you get a notification whenever I upload a new video. Thanks for watching. Don't forget to subscribe.